Hello and welcome to Tech Unplugged. Today, we're going deep, really deep into web application security testing.
Yeah, this is a big one.
It is, and I think it's something that, if you're into tech and like to know how things work, you've definitely heard people talking about cybersecurity.
For sure. It's everywhere these days.
Yeah, but we're going beyond just, the headlines. We're going to get into how security pros actually find those weak spots in web applications.
It's like getting a backstage pass to how those security experts think.
Exactly. Yeah. So, where do we even begin with something as massive as web application security?
Well, I think it's important to start with the frameworks and methodologies that guide these security assessments. The fundamental thinking behind it all.
Okay, so we're talking about the core philosophies and structured approaches,
Mm.
right? Like not just, randomly poking around, but having a plan.
Precisely. One older but still relevant framework is the Information Systems Security Assessment Framework, or ISAF. And it's not the latest thing, but it had a really important insight. Treat security testing as a complete life cycle from start to finish.
So like a full investigation, right? From the first clue to the final report.
Yeah, and ISAF emphasized that it's not just a technical thing. You need to think about how you manage the project, what you're testing, the tools and techniques, and then what you do with the findings afterwards.
So it's not just about finding the vulnerabilities, but also about understanding the whole process and context, right?
Exactly. And the technical guidance in ISAF is extensive. I mean, we're talking about reviewing security policies, doing risk assessments, and then getting into very specific technical stuff.
Like what?
Well, it covers things like password security, different operating systems like Unix, Linux, Windows, how secure databases are, and network security too.
Network security.
Yeah, like how secure your wireless network is and the devices on your network, like switches, routers, firewalls, all that stuff.
Oh, wow. That's a lot of ground to cover.
And it doesn't stop there. They also get into things like intrusion detection systems, VPNs, antivirus, and of course, web application security itself.
Right, because that's our focus here.
Yeah, but they even touch on more niche areas like storage area networks, internet user security, older systems like AS400, and different ways to audit code for vulnerabilities.
Auditing code.
Yeah, like looking at the source code, the original instructions, and also the compiled code, what the computer actually runs. It's really quite comprehensive.
So it's like looking at the application itself, the environment it runs in, and even the human factor, right? Like social engineering and physical security.
Exactly. And beyond just identifying vulnerabilities, ISAP provides guidance on incident analysis, log review, business continuity, disaster recovery, security awareness training, and even legal aspects like NDAs.
Wow, it really is like a blueprint for building a secure organization. So you said it's not actively maintained anymore. So what other resources do security testers use?
Well, there's the PTI Data Security Standard, which is very important if you handle credit card information.
Right, makes sense.
And there's a more general Pentest standard, and the Open Source Security Testing Methodology Manual, or OSSTMM.
OSSTMM. Okay.
Then we have guidance from organizations like NIST, HIPAA, and even practical resources like the Penetration Testing Framework, guides for mobile app security, and toolkits like Kali Linux.
So it's a whole ecosystem of knowledge constantly evolving.
It is, and it's crucial to stay up to date.
Okay, so we've talked about testing after the fact, but what about building security in from the start?
Right, that's a key idea, and that's where the Owasp testing framework comes in.
Oh, WASP? Yeah, I've heard of that.
It's all about shifting security left, integrating it into the entire software development lifecycle.
So catching those flaws early on before they become bigger problems.
Exactly. And OWASP breaks it down into stages. Stage 1 starts even before any code is written.
Really? What do you do at that stage?
Well, it's all about setting up a secure development process, defining security policies, standards, and making sure everything is well documented.
So laying the groundwork for secure development, right?
Yes, and a crucial part of that is defining clear and unambiguous security requirements. For example, if a requirement says users must be registered to access content, it needs to be absolutely clear what that means. Does it mean just having an account or being logged in?
Yeah, that level of detail is really important, isn't it?
Absolutely. And then you need to think about things like user management, authentication, authorization, data confidentiality, integrity, accountability.
Those are like the core security concepts, right?
They are. And OWASP also covers session management, transport security, system segregation, and compliance with all the relevant regulations.
So it's a very comprehensive initial assessment of what security needs to be in place.
It is, and once you have those requirements, you move on to stage 2, which is security in the design phase.
Okay, so this is where you start actually planning the system, right?
Exactly. And this stage involves reviewing the security architecture and design documents, looking for potential weaknesses.
So it's like catching flaws in the blueprint before you even start building.
Precisely. And a crucial part of this stage is threat modeling, trying to anticipate what could go wrong, what an attacker might try to do.
Right, because if you can think like an attacker, you can build better defenses.
Exactly. And Owasp also recommends using modeling languages like UML to visualize the system and its security.
UML, that's a unified modeling language, right?
Yes, it's a way to visually represent the structure and behavior of a system.
And these models can help identify design weaknesses that might not be obvious just from reading text descriptions.
Exactly. And if you find weaknesses at this stage, the system architects can go back and make changes before any code is written.
So much easier to fix things at this point.
Absolutely. Then we move on to stage 3, which covers security during the development phase.
So now the code is actually being written.
Yes, and one technique they recommend at this stage is the code walkthrough.
Code walkthrough.
Yeah, this is where the security team sits down with the developers and goes through the code, but at a high level.
So not line by line.
Not at this point.
Yeah.
It's more about understanding the overall structure and logic of the code.
Like the big picture.
Yeah, the developers explain their design choices, and the security team can ask questions and point out potential issues.
Okay, so it's about building that shared understanding between the security and development teams.
Exactly. Now let's talk about a fundamental aspect of web security: protecting data in transit.
Right, making sure sensitive information is kept safe as it travels across the internet.
And this is where SSL/TLS comes in. HTTPS.
HTTPS, right, the secure version of HTTP.
Exactly. And it's crucial to test the strength of that encryption
Yeah.
and make sure it's configured correctly.
So HTTPS is all about encrypting the data and authenticating the server you're talking to, right?
Exactly. It uses digital certificates to verify the server's identity.
And sometimes, for extra security, users can also be authenticated with certificates.
Yes, client certificates, but that's less common.
Right. So when you connect to a website using HTTPS, your browser checks the server certificate to make sure it's valid and that you're actually talking to the real website.
That's the SSL handshake.
SSL handshake. Okay. So what are some key things to check when testing SSL TLS?
Well, first, you need to make sure the certificate itself is valid. That means checking the issuer, the expiration date, and making sure the name on the certificate matches the website you're trying to access.
Right, because if any of those things are wrong, it could be a sign of something suspicious.
Exactly. You also need to check the certificate's chain of trust. Making sure it was issued by a trusted certificate authority, or CA.
CAs, those are like the organizations that vouch for the authenticity of certificates, right?
Precisely. And your browser has a list of trusted CAs built in. If a certificate wasn't issued by a trusted CA, your browser will usually warn you.
Makes sense. You wouldn't want to trust your bank's website if it had a certificate from some shady organization.
Exactly. And then you need to test for specific vulnerabilities in the SSL/TLS implementation itself.
Like what?
Well, there are vulnerabilities like Beast, Crime, Heartbleed, and many others.
Oh, wow, those sound serious.
They are. Beast exploited a weakness in how TLS handled encryption, and Crime took advantage of TLS compression, which can be a security risk.
So even if you're using HTTPS, there could still be weaknesses in how it's implemented.
Absolutely. And that's why it's so important to use tools to scan for these vulnerabilities and make sure everything is up to date.
Right, because new vulnerabilities are found all the time.
They are. And tools like SSL Scan, SS Audit, and Tenable Nethys can help identify these issues.
Those are all automated tools, right?
Yeah, but it's also important to do some manual checks, using tools like OpenSSL or by carefully examining the output of the automated scans.
Okay, so it's a combination of automation and human expertise.
Always. Now let's talk about another area of cryptography testing. Padding oracles.
Padding oracles.
Yeah, these are vulnerabilities that can occur when a system uses block encryption and leaks information about whether the padding in a block is correct or not.
Padding, that's like extra data added to make the blocks the same size, right?
Exactly. And an attacker can exploit this by sending specially crafted messages and observing how the server responds.
So they're basically looking for subtle differences in error messages or timing that indicate whether the padding is valid.
Precisely. And this can allow them to decrypt data or even forge valid ciphertexts.
Wow, that's pretty sneaky. So you need to be very careful about how you handle padding and make sure you're not leaking any information.
Absolutely. Now let's talk about testing for weak encryption in general.
Okay, so this is about making sure that the encryption algorithms themselves are strong, right?
Yes, and that they're implemented correctly. For example, when you're using AES, which is a common encryption algorithm, the initialization vector, or IV, needs to be truly random and unpredictable.
FAR-V, that's like the starting value for the encryption process, right?
Yeah, exactly. And you need to use a secure random number generator for that. Also, for certain algorithms like RSA, specific padding schemes are recommended.
Padding schemes.
Yeah, like OAEP for encryption and PSS for signatures.
Hmm.
And there are also some algorithms that are just considered weak and should be avoided altogether.
Like what?
Well, MD5, RC4, DES, Blowfish, SHA1, those are all considered weak these days.
Okay, so you need to stay up to date on which algorithms are considered secure and use the right padding schemes.
And also the key length matters. Using keys that are too short significantly weakens the encryption.
Key length, right. That's the size of the secret key used for encryption.
Exactly. So it's not just about using encryption, it's about using it properly.
Makes sense. Now let's shift gears a bit and talk about business logic flaws.
Business logic flaws, these are interesting.
Yeah, they can be tricky.
They are because they're often very specific to the application and how it's supposed to work.
Right, it's not about technical vulnerabilities, but
Right.
about flaws in how the application's logic works.
Exactly. For example, imagine a website with a multi-step process, like a checkout process. What if an attacker can skip a step or manipulate the order of the steps?
Oh, yeah, that could lead to problems.
It could. And automated scanners often miss these kinds of vulnerabilities because they require a deep understanding of the application's logic.
So it's more about human intuition and creativity, right?
It is, and it's where the skill of the tester really comes into play.
So what are some specific areas of business logic that testers focus on?
Well, one is data validation, making sure that the application correctly checks and sanitizes any data that users input.
Right, because if you can sneak in bad data, it could cause all sorts of problems.
Exactly. And this goes beyond just basic checks like making sure an email address is in the right format. It's about making sure the data makes sense in the context of the application's logic.
Okay, so like if you have fields for quantity and price, you shouldn't be able to enter a negative quantity or a ridiculously high price.
Precisely. Another area is integrity checks, making sure that the application prevents unauthorized modification or deletion of data.
Right, because if someone can tamper with the data, that could be really bad.
It could. And testers will try things like modifying hidden fields and web requests, manipulating database queries, and even trying to change log files.
Hidden fields, those are like pieces of data that are sent along with a web request but aren't visible to the user.
Exactly. And sometimes manipulating those fields can allow you to bypass security checks.
Sneaky.
It is. And then there's testing for vulnerabilities related to the timing of processes.
Timing of processes.
Yeah, like can an attacker learn something by observing how long it takes for certain actions to complete? Or can they manipulate the system by delaying certain actions?
Interesting. So like if a price is based on the time you log in, an attacker might try to log in at a certain time and then delay the purchase to get a lower price.
Exactly. And then there's testing for limits on how many times a function can be used.
Limits, okay.
Yeah, like if you're only supposed to be able to apply a discount code once, can you find a way to apply it multiple times?
Right, so you're trying to bypass those limits, see if they're properly enforced.
Exactly. And finally, there's testing for the circumvention of workflows.
Workflows?
Yeah, the sequences of steps that users are supposed to follow in a business process. Can you skip steps, do things out of order, and cause the system to behave in unexpected ways?
Okay, so you're really trying to break the application's logic in any way you can.
We are. And business logic flaws can be really serious, so it's crucial to test for them thoroughly.
Makes sense. Now let's talk about WebSockets.
WebSockets, yeah, these are becoming increasingly common.
They are.
And they require their own set of security considerations. For example, you need to make sure that the server properly validates the origin of a WebSocket connection. Yeah, like where the request is coming from. If the server doesn't check this properly, an attacker might be able to make connections from a different website and potentially do things like steal data or perform actions on behalf of the user.
So it's like a cross-site scripting attack, but with WebSockets.
In a way, yes. And then you also need to make sure that WebSockets are used securely. Use WSS, which is the secure version, if you're transmitting sensitive data.
WSS, okay, that's WebSockets over TLS, right?
Exactly. Now let's shift our focus to client-side security.
Client-side security, so now we're talking about what's happening in the user's browser.
Yes, and one common vulnerability to test for here is DOM-based cross-site scripting, or XSS.
DOM-based XSS, right? This is different from the other types of XSS because it's not about flaws in the server-side code, but in the client-side JavaScript.
Exactly. The vulnerability lies in how the JavaScript code handles user input and modifies the document object model, or DOM.
DOM, that's like the structure of the web page, right?
It is. And an attacker might be able to inject malicious code that gets executed in the user's browser.
So to test for this, you need to actually look at the JavaScript code, right?
Yes, you need to do gray box testing, which means analyzing the code to identify potential sinks, which are places where user input is used, and sources, which is where that input comes from.
Sinks and sources, okay.
And then you need to test those manually to see if you can inject code that gets executed.
Another client-side vulnerability is client-side URL redirect vulnerabilities.
Yeah, these can be nasty.
They can, because if an attacker can control the URL that the browser redirects to, they could send users to malicious websites.
Exactly. It's often used for phishing attacks, where the attacker tries to trick the user into entering their credentials on a fake website that looks like the real thing.
And because the redirect seems to be coming from a legitimate website, it can be very convincing.
It can. So it's crucial to validate and sanitize any URLs used for redirects.
And what about cross-origin resource sharing, or CORS?
CORS is a mechanism that allows websites to load resources from different domains, but in a controlled way.
Right, because browsers normally have this same origin policy that prevents websites from accessing data from other websites.
Exactly. And CORS provides a way to relax that policy, but it needs to be configured very carefully.
Otherwise, you could have vulnerabilities where one website can access data from another website without permission.
Precisely. And testing CORS involves checking the various HTTP headers that are used to control these cross-domain requests.
And what about Adobe Flash? Is that still something we need to worry about?
Well, Flash isn't as common as it used to be, but there are still some websites that use it.
Okay, so it's not completely dead yet.
Not yet. And Flash had its own set of security vulnerabilities that attackers could exploit.
Like what?
Well, there were issues with how Flash applications handled variables, interacted with the browser, loaded external files, and handled redirects.
So you could have things like cross-site scripting, data theft, and even malicious redirects, all within the context of a Flash application.
Exactly. And testing Flash security involved analyzing the Flash files themselves, looking for these kinds of vulnerabilities.
And what about clickjacking?
Clickjacking is a technique where an attacker tricks a user into clicking on something on a web page, but they're actually clicking on a hidden element from a different website that's been overlaid on top.
So it's like a visual trick, right?
It is, and it can be used to make the user perform actions on a website without realizing it.
Wow, that's pretty sneaky. How do you test for that?
Well, you need to identify pages on the target website that take user input, and then see if you can embed them in a hidden frame on a different website.
And if you can, then an attacker could potentially trick users into clicking on things on that hidden page.
Exactly. And there are various techniques that attackers can use to try and bypass the defenses against framing, like disabling JavaScript or exploiting certain browser features.
So it's important to make sure your website has robust defenses against clickjacking.
Absolutely. Now, let's step back and talk about the overall process of web application security testing.
Okay, so like the big picture of how it all works.
Exactly. Web application security testing is a methodical process of evaluating an application's security controls for weaknesses.
Right. It's not just about randomly running tools and hoping for the best.
No, it's a structured approach.
Yeah.
And it often starts with a passive phase of information gathering.
Information gathering. Okay.
Yeah, this is where the tester observes the application, interacts with it normally, and tries to understand how it works.
So like reconnaissance.
Exactly. They'll use tools like HTTP proxies to capture and analyze the traffic between their browser and the application.
So they can see all the requests and responses going back and forth.
They can.
Yeah.
And this helps them identify potential attack vectors.
Attack vectors, those are like the different ways an attacker might try to exploit a vulnerability, right?
Precisely.
Yeah.
Now, one of the first things testers often do is look for information leakage.
Information leakage, okay.
Yeah, this is about finding sensitive information that's been accidentally exposed.
Like what?
Well, it could be things like configuration files, source code, database credentials, internal network information, even personal data.
And how do they find this information?
They use various techniques. One common approach is to use search engines to look for specific types of files or information.
So like using Google to search for things like password.txt or config.php.
Exactly. And there are more advanced techniques, like Google dorking, which uses special search operators to find very specific types of information.
Google dorking. Okay.
Yeah, it's a powerful technique. Testers also look at cached versions of web pages, check public code repositories, and even scan social media for leaked information.
So it's about being very thorough and looking in all the usual and unusual places.
It is. And then there's fingerprinting.
Fingerprinting.
Yeah, this is about identifying the technologies used by the application. The web server, the programming language, the database, all that stuff.
Okay, so you're trying to build up a profile of the target.
Exactly. And knowing the specific technologies helps you identify known vulnerabilities that you can then test for.
Makes sense. How do you do fingerprinting?
Well, there are various techniques. One is to look at the HTTP headers that the server sends back. These often contain clues about the web server software being used.
Right, because those headers are like little pieces of metadata that are sent along with every web request.
Exactly.
Okay.
And you can also look at the HTML source code of the web pages, looking for specific tags, comments, or even the way the code is formatted.
So you're looking for those telltale signs that give away the technologies being used.
We are. And there are tools that automate this process, like WhatWeb and Wapalizer.
Well,
Wapalizer, okay. Yeah, they're really useful for quickly identifying the technologies behind a website.
Now, once you have a good understanding of the application and its technologies, you can start looking at its configuration, right?
Exactly. Configuration management is a crucial aspect of security.
Right, because if the application isn't configured properly, it doesn't matter how secure the code is.
Exactly. And one area to look at is the application's event logs.
Event logs, those are like records of what's happening on the system, right?
They are. And they can contain a lot of sensitive information, like usernames, passwords, internal IP addresses, even personal data.
So if those logs aren't properly protected, an attacker could gain access to that information.
Precisely.
Yeah.
And it's also important to make sure logs are rotated properly, compressed, and have the right permissions set.
Rotated, compressed permissions. Okay.
Yeah, it's all about good log management practices.
Makes sense. And another thing you mentioned was checking for old backup and unreferenced files.
Yeah, those can be a goldmine for attackers.
How so?
Well, they might contain sensitive information that's no longer used but hasn't been properly deleted, like database credentials, configuration files, or even old source code.
Right, because if you can find those files, you can learn a lot about how the application works and potentially exploit vulnerabilities that have been fixed in newer versions.
Exactly. And backup files can be especially dangerous because they often contain a complete snapshot of the system at a particular point in time.
So it's crucial to have a good process for managing backups and deleting old files securely.
Absolutely. Now let's talk about enumerating infrastructure and application admin interfaces.
Enumerating, that means like discovering, right?
Yes, finding all those hidden admin pages and login panels.
Because those are often prime targets for attackers, right?
They are. And testers will use various techniques to find them. They'll try common URLs like admin or administrator. They'll look for specific file names like admin.php or login.jsp.
And they'll scan for subdomains like admin.example.com.
Exactly. And once they find those admin interfaces, they'll try to bypass authentication or brute force the credentials.
Brute force, that means trying lots of different usernames and passwords, right?
It does. And when doing gray box testing, they'll also examine the server and application configuration to make sure it's hardened.
Hardened meaning like properly secured, right?
Exactly. Checking things like IP filtering, default credentials, and separation of duties between regular users and administrators.
Okay, so it's about finding those backdoors to the system and making sure they're locked down tight.
Precisely. Now let's talk about HTTP methods beyond GET and POST.
GET and POST, those are like the most common ways to interact with web servers, right?
They are. GET is used to retrieve data, and POST is used to send data, like submitting a form.
Right. So what other HTTP methods are there?
Well, there's put, delete, head, options, and trace.
And why would you test those?
Because sometimes servers might respond to those methods in unexpected ways, potentially revealing vulnerabilities.
Okay, so like if a server responds to a delete request without proper authentication, that could be a problem.
Exactly. And the trace method can be a security risk because it echoes back the request, including any cookies, which an attacker could potentially exploit.
So it's important to test all the HTTP methods and make sure the server only responds to the ones that are absolutely necessary.
Absolutely. And then there's file permissions.
File permissions, right? That's about who's allowed to read and write files on the server.
Exactly. And it's important to make sure that permissions are set correctly to prevent unauthorized access.
Otherwise, an attacker might be able to read sensitive files or even modify system files.
Precisely. And there are tools that can help you check file permissions, like Windows Access Enum and Access Trike for Windows, and the nemi command for Linux.
So it's another important aspect of security hardening.
It is. Now let's talk about the user registration process.
User registration, okay?
Yeah, this is the process of creating a new user account.
Right. And it's important to make sure that process is secure, right?
Absolutely. Because if an attacker can manipulate the registration process, they might be able to create accounts with elevated privileges or gain access to sensitive information.
So what do you test when testing user registration?
Well, you need to check who's allowed to register, if registrations are vetted, what kind of identity verification is required.
Identity verification, like, do you have to provide an email address or a phone number?
Exactly. And then you need to test the registration process itself to see if you can bypass those verification steps or submit invalid data.
So it's about making sure the registration process is robust and can't be easily manipulated.
It is. Now let's talk about account enumeration and guessable user accounts.
Account enumeration, guessable user accounts, okay.
Yeah, this is about testing whether it's possible to figure out valid usernames just by interacting with the application.
So, like, if the login page gives you a different error message depending on whether the username exists or not.
Exactly. That can allow an attacker to build up a list of valid usernames and then try to brute force the passwords.
So a good practice is to give the same generic error message regardless of whether the username exists.
Exactly. And then you need to make sure that credentials are transported securely.
Credentials, that's like the username and password, right?
It is. And they should always be transmitted over HTTPS, never HTTP.
Right, because otherwise anyone sniffing the network traffic could see them in plain text.
Exactly. And then there are remember password features.
Remember password, those are convenient for users, but they can also be a security risk, right?
They can, because if an attacker gains access to the user's browser, they might be able to retrieve those stored passwords.
So it's important to make sure those passwords are stored securely and that they're not easily accessible to an attacker.
Absolutely. And then there's the browser cache.
Browser cache, that's like where the browser stores temporary copies of web pages and resources.
Yes. And you need to make sure that sensitive information, like credit card details, is not stored in the cache.
Right, because if it is and someone gains access to that computer, they might be able to see that information.
Exactly. And then there's password policy.
Password policy, that's like the rules for how strong passwords have to be.
It is. And testing password policy involves checking things like the minimum length, the required complexity, and whether old passwords can be reused.
Right, because a strong password policy is one of the most basic but important security measures.
It is. Now let's move on to authorization testing.
Authorization testing, this is about checking who's allowed to do what within the application, right?
Yeah, exactly. And one common vulnerability here is directory traversal.
Directory traversal.
Yeah, this is where an attacker tried to manipulate file paths to access files outside the web server's root directory.
So like trying to trick the server into giving them access to system files or configuration files.
Precisely. And there are variations of this, like file include vulnerabilities, where the attacker tries to get the server to include a malicious file.
Okay, so it's about making sure the server doesn't let anyone access files they shouldn't.
Exactly. And then there's insecure direct object references, or IDOR.
IDOR, okay.
Yeah, this is where the application uses user-supplied input to directly access internal objects without properly checking permissions.
So like if you can change a parameter in the URL to access someone else's data.
Exactly. And testing IDOR involves trying to manipulate those parameters to see if you can access data you shouldn't.
Now let's talk about session management testing.
The session management, right? This is all about how the application tracks who's logged in and what they're allowed to do.